So thank you very much, Luigi and Stefan and Stan, for inviting me here today. I'm very pleased to be part of this audience and conference. So what do I mean by bootstrapping the syntactic bootstrapper? Some people who work in language acquisition know this very well. For the others who come from the machine learning community, there's this hypothesis that was put forward by Lila Gleitman in the 1990s that is called syntactic bootstrapping. And what she means by this is that kids might use the syntax of the sentences in which they hear words they don't know yet in order to guess the probable meaning. So how does it work? You see it here. You have sentences like with a verb like think. And with a verb like think, you can have a sentence like, I think that he will come tomorrow. That's a perfectly good sentence for every thought verb in every language of the world, right? You can have a whole proposition as a complement of a thought verb. And if you have a transfer verb like give, you can say a sentence like, I give a book to John. But you cannot exchange the two verbs from the two sentences. This doesn't work very well, okay? You cannot say, I give that he will come tomorrow, or I think a book to John. And in fact, if you were trying to figure out what the second sentence might mean, I think a book to John, well, it would work pretty well in an alternative reality, right? Where you can transfer objects with the power of your thought. So you could, yes, transfer a book to John using the power of your thought. That's what this sentence would mean. And what this illustrates is two things for us. So one is that kids who don't know the meaning of words could use the syntax of the sentences in which they hear them to narrow down the probable meaning of that word. So it doesn't tell you exactly what it means. But in a case like this, if you've identified that a verb you don't know has a whole proposition as a complement, then it means it's a thought verb or a communication verb. These are the two kinds of verbs that will take a whole proposition as a complement. And the other thing is that really, if you think of a word as having a meaning and a grammatical category, you know, like this mental dictionary picture we use, where you think of a real dictionary that we would have in our heads, that might be a wrong picture. Because you see here that when you get a sentence like, I think a book to John, in fact, the meaning of think depends of the sentence in which it is. So the meaning of words is also computed in context, right? Not just as a list. I'll get back to this later, probably. And so there's lots of experimental work showing that indeed young children do that kind of inference, right? They use the syntax of the sentences in which they hear words they don't know in order to infer that probable meaning. Okay, so this begs the question of how kids learn something about the syntax of the language in order to learn the word meanings, right? And people have been working on that a lot. And two sources of information have been put forward as particularly informative. So one is phrasal prosody. So that's the prosody of sentences that chunks sentences into groups of words. And these groups of words correspond to the syntactic units, not perfectly, but the boundaries of the prosodic units correspond to boundaries of syntactic units. And again, there's lots of work, I've cited a few here, showing that very young children pay attention to phrasal prosody. The other things that kids could use is the function words and morphemes, so things like articles, auxiliaries, also termination of conjugation termination and stuff like that. And again, there's lots of work showing that very young children pay attention to these highly frequent morphemes. And so if you put the two together, you see that you could get something that would help you figure out the meaning of words, which I've called the syntactic skeleton. So if you have a sentence like, the little boy is eating an apple, if you're speaking slowly enough, you're likely to make 3 units out of this, like the little boy is eating an apple. That's the way you would talk. And then if you look at the morphemes, you have here the, is, ing, and. These are highly frequent syllables in English. They occur at the edges of the prosodic words. If you figure out what kind of objects they are, you could then infer that in this first prosodic unit here, you're likely to find a noun because this the here will co-occur with nouns, okay? So now I'm going to show you a bunch of experiments with very young kids, trying to show you whether this is indeed true. So here's the first one, showing that very young children, in that case 18 months old, indeed recognize words in context and not just as abstractions, right? So I'm starting here with the first set of experiments that were done by people like Renate Zengel and Anne Fernald. And they showed something very simple. So you show pictures of objects to 18 months old, for instance, a dog and a car. And if you give them a properly formed sentence, like look at the dog, then they are faster to look at the dog rather than the car, than if you say something like look at dog or look at was dog, where you put something strange in there, okay? So they can use the context of the sentence to get to the sentence faster. Another result that was pretty counterintuitive at the time, and that is very interesting to us, is that Dan Swingley and Dick Aslin back then tried to teach 18-month-old, again, novel words. And they found out that if you try to teach them a novel word that is very close to a word they already know, in that case, tog, which is close to dog, then they cannot learn it. And the novel object they were using was a kind of dinosaur. So if you try to teach 18-month-old that tog means dinosaur, the kids just don't learn it. And this was very strange to people because we knew very well that 18-month-old and even 12-month-old and even 6-month-old make a distinction between the and t. Okay, these sounds are different for them. We know they do it. So why do they find it hard? And so the reinterpretation I want to offer here of this result, and we did that with Dan Swingley, is that actually it's not that kids are confused between the and t in a case like that. It's just that they're good statisticians. So now think that you're an 18-month-old, your lexicon is mostly empty. Okay, so here I'm picturing the phonological space, so you know dog, and baby, and mommy, okay, you know, a handful of words. And now I'm teaching you one novel word. What is the probability that this one novel word will land right next to one of the words you know already? So tog next to dog. Well, that is pretty low, actually. And that's what kids are probably computing. They're confused. So how can we test that? Well, if kids indeed process words in context, we know that we have different syntactic categories, right? And so now if I'm using I'm teaching them a novel noun for a novel animal, let's say. If I'm using a noun neighbor, so a word that is very similar to a noun they know already, then they should be confused, indeed. However, if I'm trying to teach them a verb neighbor, so a word that is phonologically very similar to a verb they know, then they shouldn't be confused. So to keep the analogy, if we have here the space of nouns and somewhere else the space for verbs, then they shouldn't be confused if one appears to be phonologically similar to the other. So the examples in French are words like un parti, which is close to parti, which means gone, which would be in English the equivalent of a kiv. So in this experiment, kids first watch a short video here. This is the novel animal, and I'm playing with the animal and naming it and using every possible way that will help the kids learn the word. So all the natural pedagogy things, looking at the object, looking at the child and alternating the gaze, everything, okay? We give them every clue we can. And they learn two words, the noun neighbor and the verb neighbor. And just, I'm going to say this once. So these little labels here mean that this study was pre-registered. So before we ran it, we explained why we wanted to do it, what kind of analysis we would run on it. The data are open and the materials as well. Okay, so whenever a study is like this, you will see these little badges appear. And I'll jump to the results right away. So here on this graph, this is a looking experiment, I should have said, and we're monitoring what they're doing with an eye tracker. Okay, so they have these two images side by side, and this one is the Ganard, and this one is the Barty, and we're going to ask them, look at the Ganard or look at the Barty, okay? And so in red, you see here what they do with the noun neighbor, the Ganard. And we replicate very nicely the results of Swingley and Aslin. The kids do not learn that. They're very confused. They have no idea where to look. If you teach them a verb neighbor, however, they're very happy to learn that novel word. In fact, it's just as well for them as if it were a word that doesn't sound like anything in their lexicon. Okay. And this was work by Isabelle d'Autriche in her PhD. She went further than that. She said, after all, there's lots of homophones in natural languages. And maybe the reason why we're not bothered by homophones is that we process words in context. And therefore, kids might be able to learn these homophones as well. So she did that directly. She said, okay, I'll take a verb that they know really well. This is parti, it means gone. Okay, they know that. And I'm going to teach them that this little animal here is called un parti. And the control one was something that doesn't sound like anything in French, un torba. And you see here again that they learned this really well. So that's the proportion of look to target, and this is time. You see the word is presented here once, then a second time. And in both conditions, they're very good at looking at the correct word. So what this shows us is that, indeed, kids process words in context, and they accept that the same phonological form could be used several times, so long as the words are distinguished by the context. And actually, I just mentioned this briefly. Isabelle d'Autriche went further than that, and she did an analysis of the lexicon of natural languages, a bunch of them. And she showed that, indeed, natural languages avoid the homophones, which belong to the same syntactic category. Okay? So they prefer homophones, which belong to different syntactic categories, because they are not a problem for processing. Okay, so these experiments, and a bunch of them, show us that infants are indeed sensitive to the syntactic contexts of words. Okay, so they can exploit the syntactic category of a novel word to infer whether it refers to an object or an action. That's other studies that I haven't presented. And the problem that people often raise in that case is that it's not always the case that every novel word is preceded by a nicely disambiguating functional word just before it or just after it. And so you have cases like I've put here, where you could have an ambiguous whole sentence. Like if I say, "Do you see the baby blicks?" then I'm talking of little objects, right, baby blicks. And if I'm saying, "Do you see the baby blicks?" then I'm saying that the baby is actually blinking, okay? So in that case, we have the same string of words, and only the prosody will help you figure out what the syntactic structure of the sentence is and what the syntactic category of that blick word is. Okay, so can kids do the same thing? So this is a first experiment. Again, kids are watching two pictures. In that case here, a baby mouse, and here a little baby smiling. And in French, the word for mouse and for smile are homophones. So you can say, "Regarde le bébé sourit," and it means look at the baby mouse. And if I say, "Regarde le bébé sourit," then I'm saying, look, the baby smiles, okay? And just the prosody will allow you to make this distinction. Adults do it very well. And 20-month-old French-speaking children do that as well. So here you see that when they listen to that sentence here, they look more towards the mouse than when they listen to the blue sentence here, where they look more towards the baby. So that's with words they already know. Can they also do this with words they do not know yet? Okay. So that's another set of experiment. And this one, because we're trying now to test teaching not just novel nouns, but also novel verbs, this one is using a different technique. Because if you try to present two videos to children and ask them to look at the correct one, this is too much things happening at the same time. Young children don't do it. So this one is instead a habituation experiment. They see only one thing at a time. Okay? So first, they watch this one video, and we teach them a novel verb on that one. So it's doing this strange action, and we're telling them, "Oh, look, elle doripe." If this will work.
Oh, regarde, elle doripe. Tu la vois qui doripe?
And this is playing as a loop for as long as they will watch, okay, like 30 seconds. And then once they've finished looking at this one, they look at this other one. The same penguin is doing a different action. Now we're teaching them a novel noun on this one. Sorry, I can't seem to be able to make it play.
Oh, regarde, c'est une bamoule. Tu la vois, la bamoule?
Okay, so we adults, when we listen to a novel verb for that particular video, we learn that probably the verb refers to the action, and therefore we infer that doriper means cartwheeling, okay? And when we hear a novel noun for this other video, we infer that probably the novel noun refers to the penguin, and therefore we think that bamoule means penguin, okay? How can we test whether the kids do the same kind of inference? In that case, this was an idea by Angela Hay and Jeff Leeds. We just replicated this here in French. They just exchanged the two soundtracks of the two videos. And now we're going to check how surprised the kids are to listen to that. And we're measuring that by how long they're willing to listen to that video. So when you exchange the two soundtracks, you see that now we have this video where the penguin is cartwheeling, and we're saying, "Oh, regarde, it's a bamoule." And if bamoule means penguin, then this should be perfectly okay, right? It's still a penguin here. And for this one, we're now saying on the spinning penguin, "Oh, look, it's doriping." And if dorip indeed means cartwheeling, then they should be surprised because that penguin is not doing something different, okay? It's not cartwheeling. So we expect them to not be surprised here, not look particularly long, and be surprised here, look longer. And this is exactly what we find here. So in the noun switch condition here, we present here the average looking time, you see about 12 seconds, for the last 2 trials before the kids got habituated, and for the 2 test trials, and you see that it's about the same. And for the verb switch children who heard the novel verb with the different action, you see that there is an increase in looking time between the last 2 trials of habituation and the 2 test trials. So that's with plain function words, right? Elle, Dori, and c'est une bamoule. He did the same thing exactly with the prosody manipulation. So now here you have, oh, regarde la petite Dorip, meaning the little one is Doriping, or, oh, regarde la petite bamoule, meaning look at the little bamoule. And the kids do exactly the same thing here. You see that the verb switch kids are surprised relative to the noun switch children. So what this shows us is that these 18-month-old children are indeed able to use phrasal prosody in conjunction with function words to interpret whether a novel word is a noun or a verb, or likely to refer to an object or an action. Thank you. And so the question is how toddlers manage to learn these noun and verb contexts, right? So the idea we put forward is that perhaps children rely on their knowledge of a few known nouns and verbs in order to learn the context in which they appear. So the idea would be like this. There are experiments, for instance, by Bergenson and Swingley, showing that 6-month-old and 9-month-old already know some very common nouns and verbs. We know that children tend to group words together. We know that children group objects or actions together, like they have an agent category. And if they can group words representing objects together and words representing actions together, these could serve as a seed for future syntactic category. And so how can we test this? In that case, we used a model, a corpus of child-directed speech, and we trained a model where only a few nouns and verbs were categorized. So in the very smallest size of vocabulary, only 8 nouns and 1 verb were supposed to be known. And the idea here is that the child managed to learn them through pure observation of the environment. And then the model is simply collecting trigram frequencies. This is an extremely stupid model. So in the same idea that Emmanuel was saying before, if the model is simple, then it can interpret what the model is actually doing. So this one is particularly stupid. It's just collecting trigram frequencies. Then we test it on a test corpus. It will stop on every word that is not too frequent, like cat here, and attempt to categorize it by looking at its immediately preceding context, in that case, beginning of sentence followed by le. And it will give as answer the thing that occurred most frequently in that context. So let's say that in this context, it heard most often things that belong to its noun category, things like bottle and baby. Then it will say noun. But if in that particular place he heard mostly book, and book doesn't belong to the words he's supposed to know, then the model will say, oh, I think this is book, okay? And we will count it as a mistake. So there's 2 measures which are really classic. So precision is the number of hits. So a hit is whenever the model thinks it is a noun, and it is really a noun, divided by the total number of hits plus false alarm. So false alarm is when you think it is a noun, but really it is not. And recall is hits divided by hits plus misses. Misses is whenever there is a noun and you don't find it, okay? So I'll show you the results right away. So you get the results for nouns here and for verbs here. In black, this is a chance model, just to see what you would do by chance. And in red, you have the precision and the recall for that model. So 2 things. You see first that precision is very high for nouns and for verbs, and it doesn't depend on the size of the vocabulary you know initially. So when you know very few words, your precision is already very high. As you know more words, the precision doesn't increase. Recall, in contrast, is low when you don't know many words, and it increases when you know many words, which makes sense. So a way to interpret this is to say when you don't know very many words, you cannot learn many different contexts, but those contexts that you learn are good contexts. They will give you correct information as to what that word is likely to be. Okay, so what this model does, interesting points. First, it categorizes the words in context, and therefore it is not bothered by homophones, which is really good, okay, because we know that 18-month-olds are also not bothered by homophones. Second, I'll focus on that. It relies on functional items for categorization because they are so highly frequent. So when we look at what the model is doing, the context it is using, we see that it is mostly function words and morphemes that play a role in that. So the model was not built for using functional items, but it did just because they're so frequent. So now this is a plausible mechanism. We would like to know whether children actually do this. Okay, so how can we test this? Well, if we're going to try to show how they learn something about syntax, we have to teach them a new bit of syntax, just as before we taught them a new bit of the lexicon, right? Otherwise, you cannot disentangle between what they learned before and what they're learning now in the context of your experiment. So this is what we're doing here. We're teaching them a novel function word, in that case, ko. There's two groups of children. They're watching this little video of me playing with known objects, okay, like a book and a pig. And in one condition, the verb condition, every pronoun is replaced by ko. So it goes like this. Oh, look, it's a turtle. Ko plays with ko looks at a book. Now, ko will play with something else. Ko plays with the big pig, and so on. And the second group of children looks at the same video, exactly the same things that are happening, but the soundtrack is different now. Ko replaces the articles. So now it's something like, oh, look, it's ko turtle. She's looking at ko book. Now she will play with something else. She plays with ko big pig, sorry, okay? And so at test, after they have watched this video, which lasts about 10 minutes, we present them with an alternative between a novel action, this lady here is moving her arm like this, and a novel object that is presented by another lady here. And the results here, you see that both in their pointing responses and in their looking behavior, the verb group here in purple tends to choose the novel action more often than the noun group in orange here, okay? And you might think, well, these are pretty old kids, right? They're 3 to 4-year-olds. We would hope that this works for younger children. So can we go younger? I told you before, we can't go any younger with videos like this because it doesn't work with young children. They get bewildered. But we can do it with nouns using more fine-grained distinctions. So I don't think I have time to play you this video, but in that one, we're teaching them two novel function words. Okay, there's ko and ka. And ko goes before every animate things like ko chicken, ko rabbit. And ka will go before the inanimates, ka book, ka tractor, okay? And we're going to see at test, we present them now two pictures of objects, one animate, one inanimate, and we ask them to look at ko bamul or ka dorip, okay? And the choice of animacy was not random because we know that's part of core knowledge, okay? That's one of the distinctions that kids do really early. And there's a lot of work, including by Brent Strickland at the DEC, showing that if you look across the languages of the world, you find marked in morphosyntax those things that belong to core knowledge. So those distinctions that are important to children. And indeed, these 20-month-olds here are able to exploit these function words that they just learned by looking at a video in order to infer the probable meaning of these novel words that they just heard, okay? So when they here look at ko bamul, let's say, they look more at this animate here than when they here look at ka dorip, where they look more at this guy here, okay? Okay, so this shows us that indeed children are able to use the words they already know, content words, in order to learn in what syntactic context they occur. And then they can use these syntactic contexts in order to learn new stuff about words they don't know yet, okay? So the question now, I won't have much time for it. I'll just give you a glimpse. I don't know how much time you have. 5 minutes, okay. So there's basically two ways to go about it, the way I think. So one is that they could gather knowledge about the grammatical structure of their language for a period of time and then start using that knowledge. Another way to go about this is that perhaps children, just like the learning neural networks, right, always attempt to predict what will come next. And when they get an unknown lexical item, one that they cannot identify, then they project the expected properties to that known, unknown item. So this is what we saw before, right? They hear, look at Cobamul, and they think, oh, I heard pig and chicken. Maybe it's something like chicken and pig, and therefore this guy, it has eyes. Okay, it's more likely than this other guy. And whenever there is a mismatch between what they expect and what they get, then they would need to change their expectations. They would need to change their language model, if you think in terms of model. So how can we test this? Well, by presenting them with mismatches and see what happens. Okay, how do kids behave? So these are, again, a bit old, like 2.5-year-olds. In that experiment, they look at, again, 2 objects, and now we're manipulating gender. So if you have a case like this, where you have 2 words starting with ba, so this is un bateau, and this is une banane, okay? And they differ in gender. So as soon as you hear, oh, look at le bas, you know to look at this one, because it cannot possibly be that one. Otherwise, I would have said, oh, regarde là-bas. Okay, there's this gender difference. And we know that kids can do that. I'll show you right away. So when indeed, this is proportion of looks to the target, when indeed the two words belong to 2 different genders, they're quite fast. If you give them 2 words of the same gender, they are slower because they need to wait until the next syllable. So now if it's le bateau here and le ballet in that one, then you need to wait a bit longer. And what we're doing now is checking the mismatches. So now we have a second speaker, a second group of kids, and that second speaker is unreliable. So he's not using gender correctly. So the test trials are exactly the same, but in the filler trial, he says strange things like, look at le grenouille. So non-French speakers don't hear it. It's strange, but it's using the wrong gender, okay? And we're trying to see what kids will infer in that case, okay? And what you see here is that when they have this unreliable speaker, well, you don't get this significant advantage for the different gender trials anyway. So they stop to use gender. And so there's 2 interpretations for something like this. One is what I just told you before, and that is that actually children change either their language model or at least their language model for this particular speaker, okay? Because we know also that we're very good at having expectations about the way the specific speakers speak. But there could be something else. They might just have decided to adopt a wait-and-see strategy for this particular experiment. So I have one last experiment. I'll try to be quick, trying to test that exactly. So this is based on the previous experiment by Johovsky and colleague. They had this thing where it says, like, I had carrots and bees for dinner, okay, which is strange. You would expect carrots and peas for dinner. And they showed that depending on the context, if you have lots of semantically funny sentences, then kids will start to go for the literal context. If you have a bit of noise in the experiment, then they will go for the semantically most plausible context. So we did the same here exactly, and the experiment is complex, so I'll just run through it by presenting them with things that are strange. So for instance, they listen to something like she apples, elle pomme, so you don't expect this. And in the semantically reliable condition, we give them a very good candidate for the content word. So basically, we tell them, well, ignore that function word here, that pronoun, and pay attention to the content word. And in another group, we don't give them an apple here, there are no apple. However, there's this lady doing a new action, which might be a very good candidate for a novel word, which would be apple, okay? So she's appling here. And what we try to see is whether at test, the semantic group will go for content words and the syntactic group for the other ones. So the test goes exactly the same as before. I'll go directly to this, which is easier to interpret. So that's the looking time. Syntax reliable kids should go towards the new action, and the semantic reliable kids should go towards the known object, okay, when they hear something like, oh, look, elle balle, she's bowling. You see here that when they hear elle, they all move to that new action. Then they hear balle, and they all move to look at the object, okay? So they follow what's happening. And then in the rest, you see that the syntactic kids recover faster to go toward that thing, which is indeed the most plausible interpretation for their version of the experiment. Here, none is significant in this. None of the time windows are significant in the most stringent test, but overall, in their pointing responses, there is a tendency that they do this. Okay, and I'll stop here just to say, so word learning is an inference process, not a simple association. And maybe we need to think of meaning in a bit differently than just as a mental lexicon. Meaning is constructed across sentences. But then I don't have a good alternative model to give you. I've been thinking about this, but I have no clear ideas yet. Thank you.